maybe a little unfamiliar, Databricks is a cloud computing platform that sits on top of things like AWS, GCP, Azure. But for us, we're moving a focus towards going from data intelligence to being able to integrate things like AI agent systems that sit on top of your data or even sit on top of your data and traditional machine learning models. Multi-agent systems are really core to this, right? In that we look to leverage either a suite of tools or even other machine learning models with existing LM capabilities. So I'll be focusing a lot on that. But just to give you kind of a broader view of where our customers are and where we see industry at large, right? The idea of having an unstructured retrieval or RAG is something that we still see customers looking to get a leg up on. Frankly, also actually see value in. Chatbots are not the end all be all, but that's kind of where we see things starting. Moving to working with actual structured data as well. You can imagine then working with both of these, right, and needing the ability to do things like routing, call different tools, et cetera, and also work with a variety of data sources. But before any customers actually get to doing multi-agents, just this process alone can take a lot of time and investment. And there's a lot of complexity involved too. It's very hard to keep track of these things. I'll talk a little bit about evaluation, but only then can we actually get to multi-agent systems or agents that orchestrate other agents. As I said at a previous MLOps community event where I was speaking, a lot of customers are just not there yet. We don't necessarily see this in industry as much as some of these other components, in part because of the complexity and the potential risks involved with multi-agent systems. So the broader development lifecycle of this really starts with data, and that's as critical as any agent framework, as any evaluation as you might do. Same with any traditional machine learning model. You might do vibe checks with quality, with LM judges, but until you actually get to the ability to understand what makes for a good or bad agent, you're still a long ways before productionalizing these things. Just the fact that we have this kind of loop here between 4 and 3, iteratively identifying and fixing root causes, and creating more evaluation data to either fine tune on or provide us in context learning examples, right? These steps can take a lot of time. I'll talk a little bit more about that iterative identification and fixing root causes, but only then will you be ready to actually get this into the hands of QA testers and be able to get feedback, and then eventually release to production. But the way we look at it is, you're always going back and identifying and fixing root causes. We see cases where you might fix one part of a prompt, but then that messes up some other downstream capability. So evaluation, right, is almost more important than anything else when it comes to building effective AI agent systems. This is a much broader overview of what that might look like on the Databricks platform. There's a lot going on, I think, in part because our customers do such a wide range of different things. But a lot of what I talked about kind of links up with what we talked about before. The data piece is all centered in Unity Catalog, which provides a unified governance structure for everything from your data to models to model artifacts. But we have customers that want to work with a range of both open source, commercial LLMs, with a variety of different agent frameworks, right? We're not, a platform that looks to lock in customers, but that observability and monitoring and evaluation capability is all done through open source MLflow, which is awesome because learning agent frameworks is hard enough. You shouldn't have to learn an entirely new evaluation framework too, and I'll show a little bit what that looks like downstream. We have a lot of different products here that I won't touch in too much detail on, but needless to say, you can leverage functions that work with any number of these products. For instance, like a RAG function or SQL functions as well, to then actually build agents and get those to production. I'm happy to talk more about any of this at any other time, but obviously a lot going on. The one thing I want to note here, though, is in talking about agents and multi-agent systems, right? There's a billion different frameworks to choose from. In talking with customers, we do see mostly LangGraph. But I've talked with people at, say, like meetup events around New York who say, why would I use any framework at all? Like, I can write Python code, I can define my own constraints. And that's something that we look to support. All these other frameworks, though, are integrated well into the system. Some of them even having their own MLflow flavors now, which makes it really easy to leverage on our platform. I'll talk a little bit about like what we do more generally from a multi-agent perspective before getting into a demo. But the big idea here, and what I think is absolutely critical to bringing these systems to production, is having some kind of supervision pattern to more to better orchestrate the overall flow of information, and as well as just capabilities within this multi-agent model, right? Um, I think the big issue more generally with Gen AI is that you have the capacity to hallucinate, and as you get increasingly complex systems, right, that makes it increasingly possible to venture off into weird sub branches of this tree here. More importantly, ensuring that structure is maintained throughout all of this is frankly just hard. I have been using LangChain in various capacities for a very long time now. It's almost 2 years. And yeah, like in the early days of LangChain, especially, that was really hard to do. I think things are improved, but you can imagine, especially if you're one of these people who's building everything out custom in Python, you're very susceptible to getting formatting issues or other kind of type constraints, right? But the solution that I'll share today for a multi-agent system looks to do two things. One is have function calling capabilities. This is leveraging our homespun vector database. We have tons of people who use external vector databases as well as Python code and pre-written SQL. And the other capability that will be leveraged here is text-to-SQL agents using a product that we call Genie. Genie is, in the easiest terms, like a text-to-SQL sits on top of all the data you might have in Databricks kind of tool. It works on top of both dashboards that we have, say, business developers or data analysts building, but it can also be called like a tool. This sits on top of Delta tables, which just think of it as like a data frame, right? The function calling piece, though, gets complicated, right? As well as the multi-agent orchestration piece, because it's not just a singular input-output, right? We need to be able to decide, have almost reasoning capabilities around what either functions or what sub-agent might be most useful for either a given question or a given type of data being input or output. So this gets complicated. I'm sure many of us are familiar with this, but with that, I will get into the demo. So what I'm going to be sharing here is a Databricks notebook. So as I said, this all sits on top of a Unity catalog data store, right? And what we'll do is we'll go through Databricks RAG Studio to obviously import things that we need, but we'll define a path of a chain, and we're going to then log that chain using MLflow to test it, and then downstream from that, register the model, right? We already have our data in Unity Catalog, but you can have your model there as well, deploy that, and then view that deployed chain in the RAG Studio UI. So you'll see here in terms of what we're doing, right? We have a lot of LangChain. We usually have customers building in LangChain, and so if you build in LangChain, things are really, really straightforward. DSPy, another agent framework, is actually something internal to Databricks. We don't want to focus as much on the uninteresting stuff, but we can kind of start with just seeing how this would work in terms of specifying what a message might look like, right? This is pretty typical kind of OpenAI formatting. And we can define what our agent might look like. This is a little more specific. One thing that you'll note here in this agent config is we have a UC function list. So UC, that's Unity Catalog. We've already had two things in our Unity Catalog, right? We had our incoming data, right? As well as the actual model itself. But we also look at AI functions as being something that you should probably have with the same governance structure, right? So if I share like this other tab here, right, you can see the Unity catalog right on the left here. So there's tables, there's volumes for who knows what, but more importantly, functions. This is a SQL function in which we kind of have a very specified structure of input and output. I think you cannot build multi-agent systems without having these very discretely defined input outputs for your downstream functions because, like I said, hallucinations and veering off forking paths. But notably, we define parameters for this with a stock name fragment that we will use to then get information about the stock item, right? We'll get a stock item ID and a stock item name based on like a particular fragment that is being supplied here. So that's basically that. You can see like the type here. Like I said, data governance really important. We can define that only certain people can actually use this function, which means one agent might do different things for different people if you want it to. Maybe you have sensitive data that you don't want your summer interns having access to, but for general employees, that might make sense, as an example. There's also other capabilities as far as tools go. So this is a tool writer capability. And what this will do is it will actually create new tools, which is awesome, right? You can imagine your AI agent system actually evolving over time. But once that is in place, actually having a wrapper for all this with agent builders, how we'll look to register this whole thing together. We have some things around vector search as well. I won't touch too into that as that's a little more Databricks specific and probably not as interesting to folks who are very familiar here. What I think is really awesome about our AI agent framework is that it's all just MLflow, right? If you have data scientists who are suddenly being asked to try to be a Gen AI engineer or specialist, that's not a fun time. Instead, if you already know MLflow, right, you don't need to relearn a whole new ability to work with agents, right? In this case, you can see we're going to call mlflow.startrun and then mlflow.python.log model. This is very, very familiar to anyone who has spent the past building traditional ML models. We have a lot of other things here in terms of like input examples, configs, etc. Not all these are required, but you'll see how it can help downstream. But you can see that this is effectively logged. And this is, again, just MLflow LangChain flavor. But you can use this with any other kind of flavor of MLflow that is for agent systems. We'll have some questions here, but you can see what we'll do here is we'll call our loaded model, which we're notably picking back up from MLflow and running that on top of a question. What I think is so, so cool about MLflow now is not only is it built out for Gen AI and can support Gen AI models, but all of what you're seeing here, this MLflow tracing, is just done for you automatically, right? Like if you are debugging an AI agent system, like it is never fun. The most important thing you can possibly do is be able to dig into this, see what is taking long, right? Like we've all had these issues where, oh, this one subcomponent, I think this is doing something with an API, is hanging up, right? Maybe it's because something got messed up in the formatting. You do not know that unless you build a good evaluation system and can rapidly iterate on it. And again, this is all just given to you for free within Databricks MLflow, which means that it's ideal for closing the overall dev loop and making it possible to get AI agent systems to production. You can see that we're calling a bunch of different things here, though, right? So our initial LangGraph is called. We're going to first initiate our initial agent, right? You can see that there's a downstream tool call here. There's another agent call, right, with another tool call, and we have another agent call doing something else, right? And yeah, we can dig down to any component of this and see everything from we're going to, in this case, get a registered model. And I think what that will do is then change some of the associated metadata there. So you can see what the outputs of that is and even what the inputs are, right? Retrieval model and Unity catalog by name, right? So the last step of this, right? Let's say that we are pretty happy with this. I haven't even shown our broader MLflow integrations, but needless to say, it's really helpful for comparing, say, swapping out DeepSeek for GPT-4o, making any other kind of changes. Actually, logging this is one thing, but getting it deployed as part of a production grade system can be a huge pain for our customers. What you can see here is when we call client.setRegisterModel alias, or sorry, when we call mlflow.registerModel, what that will do is it will make that available in Unity Catalog. And then downstream from that, we can actually get that deployed. So you see like this is another prediction on top of that. But we'll do some deployment prep, and then downstream from there, all you need to do to deploy your model is call agents.deploy. And that's it. There's some environment variables that you're setting here, secrets, which can also just be managed within Databricks. But it's super, super straightforward to be able to get this from, hey, I'm playing around with this in a notebook, which as a former data scientist, like that's awesome. And then you can actually do things around, say, setting review instructions and make it possible for subject matter experts to provide feedback on your agent system. It's one thing to just run this in MLflow and say, here's my data. It's another to then have it be tested by other people. You can see like that review app is accessible here, which you can share with people internal to your company or elsewhere, and actually get feedback on that AI agent system. That's about it in terms of what I have here today. But yeah, I kind of just want to close by saying that the state of agents is one that has changed a ton, and we've gone a long way from just having pure LLM calls. We see agents with tools. I think we need to spend a lot more time investing in lightweight tool integration. Like we shouldn't be doing math with LLMs. Ideally, we can call a calculator, right? But we also see issues with overcomplicating things. OpenAI said they're double investing in reasoning models. Well, if you're building agent systems on top of reasoning models, you can fall into double reasoning pitfalls, which are super, super painful. The other thing is, we need to think back to some of our fundamentals of agents. RL has had agents for, I'm going to say, decades. And this paper from 2017, you read this title, Multi-Agent Cooperation and the Emergence of Natural Language, and you'd say, oh, like, I know how to build that. It's actually all RL, right? I think there's a ton of valuable research there that's currently untapped around statefulness, constraining action spaces, a lot of the things that make AI agent systems successful today that we don't appreciate. Another like kind of future looking vision is open sourcing of proprietary agents. We all know like DeepSeek may or may not have taken some inputs and outputs from OpenAI, but even deep research is not that complicated for people to build. I'm really excited for the world of open source. Databricks loves open source and having people build with all sorts of different capabilities out there, and really excited to see where agents go in 2025 and multi-agents in particular. So thank you. That is all I have.
Thanks a lot, Dan. Those were all really insightful things that you shared. And feel free to share your like socials or your email so that we can send you any